All right, so in this video, I'm going to go over a couple of different examples of problems that involve some skills you might need to review. Now, on this worksheet, I definitely did not leave enough room for you to do it on this page, so please take notes and do this on, or I guess if you want to take notes on this paper and then do your homework on scrap paper, that works. Whatever works for you, just make sure that you do it on a separate sheet because you will not have enough space. All right, let's see. I'll go ahead and I will do problem 2. All right, so we've got square root of t plus 15 equals t. So what we have to do here is try and get the square root by itself. Or I'm sorry, try and get the variable by itself, right? We're solving for the variable. So what we have to do is we have to first get rid of the square root. So to undo a square root, we have to square both sides. All right, and when I square this side with the square root goes away, and I get 2t plus 15 equals t squared. All right, and then I need to go ahead and this one's kind of tricky because now we have a t squared. This is a quadratic. All right, to solve a quadratic, we can either use quadratic formula, we can factor, we can graph. I'm going to attempt to factor here. Let's see if we can get that to work. So in order to factor, or really solve a quadratic in any sense, we need to get all of the variables on the same side. I like to keep my squared term positive. So I am going to move this stuff over. All right, so I'm going to subtract 2t and subtract 15 from both sides. These guys both cancel and I get 0 equals t squared minus 2t minus 15. Now we need to go ahead and try and factor this. So we need to figure out what multiplies to give me a negative 15 and adds to give me a negative 2. So for this one, we are going to want to do a minus 5 and a positive 3. If you're struggling with that, you could just write out all the factors of 15, right? 1 and 15. There's really only two pairs. You have 1 and 15, and you have 3 and 5. Negative 5 plus 3 is going to give me a negative 2. Negative 5 times 3 gives me my negative 15. So now I go ahead, I'm going to set these equal to 0. And I get t equals 5 and t equals negative 3. All right. Awesome. So one thing you should kind of get in the habit of, we'll see this a little bit, is you have to kind of make sure that your solutions work. Because there is a square root in this original problem, what's inside of the square root cannot be negative. All right. So we could test the 5 and make sure we end up with a positive number. So we get the square root of 2 times 5 plus 15, which is going to give me square root of 25, which is 5. So that checks out and we're good to go. If we try negative 3, we get 2 times negative 3 plus 15. We get the square root of, what is this, negative 6 plus 15, which is 9. We get 3. That checks out. All right. You should always check your solutions to make sure that they work. All right. Let's go ahead then and let's do, I don't know, we could do number 8. I feel like that's going to trip people up. All right. So for number 8 here, again, we have to try and get rid of the roots here. Now, if you notice, there are cube roots on both sides. So in order to undo a cube root, you need to cube. So I'm going to cube both sides. All right, and what that's going to do is that is just going to get rid of the radical. So then I just end up with x plus 1 equals x squared minus 5. Now, unfortunately, or fortunately, I don't know if you like quadratics, we have that x squared there, which tells you we have a quadratic. So we got to factor, use quadratic formula, do something here. So I'm going to go ahead once again and get all of my terms on the same side. So I get 0 equals x squared minus x minus 6. So then I got to figure out what multiplies to give me a negative 6 and adds to give me a negative 1. That is going to be x minus 3 and x plus 2. So then I set these terms equal to 0. And I get x equals 3 and x equals negative 2. Now you don't really need to check these since this is an odd radical. If it was even radical, you should double check that you don't have a negative inside of there. You can take the root of a negative number when this value is odd. All right, let's see. I'll do one of these, I guess. So I'll go ahead and do 12. We're going to go ahead and subtract 8 from both sides. And we get x cubed equals what? 65? Does that seem right? Yeah, all right. Okay, so then we would go ahead and we have to take the cube root of both of these, and we would get x equals the cube root of 65. Now this just generally is not a super nice value. You can't simplify this radical, so this is just your answer. All right. Let's see. All right, let's try this one. Let's do number 15. So again, we're trying to get x by itself. Let's go ahead and move this 9 over. The reason I'm doing that is I want to get it so that the stuff that's being raised to the third power is all by itself. So when I do that, I get x minus 4 cubed equals 125. All right. Now to get rid of my cube, I'm going to cube root. Now some of you might know the answer just from looking at this. If you don't, that is absolutely no big deal. You can go to your calculator. So you'd go to second math. Nope, just kidding. You go to just math. And you can go back down to this cube root. What the heck? There we go. And we can put in 125 here. You see that the answer is 5. So I would do x minus 4 equals 5. So again, this cube went away because I cube rooted. Those cancel each other out. And then the cube root of 125 is 5. So then to finish solving, I would just add 4 to both sides, and I get x is 9. Now, in this case, I did not need to add in plus minus because this is an odd root, all right? If I had added in a square root, I would have had to add in a plus minus. If I had added in a fourth root, I would have had to add in a plus minus. Whenever you yourself write in an even root, you have to add in plus minus. All right, hopefully these, I think you guys will be pretty good with these. We've done a couple examples in class, but these I do want to go over a couple of them. So basically what you got to do here is these are exponents, okay? And in problems, a lot of them where you have exponents on both sides, it's a good idea to try and get the same base, okay? So the base is the big number on the bottom. In this case, they already have the same base, so all I have to do is set these exponents equal to each other to solve. So I would just do 1 minus 2n equals 1 minus 3n. All right, I'm going to do minus 1 minus 1. Get negative 2n equals negative 3n plus 2n. I get 0 equals negative n equals 0. All right, so again, what you have to do here is you want to get them with the same base, and then once you have the same base, you can set the exponents equal to each other. All right. So let's go ahead and try maybe a little bit tougher of a problem. All right, how about let's do number 9. So for number 9 here, I'm looking and I'm like, well, I've got a base 6 with this exponent. Am I able to get this into a base 6? And unfortunately, that is not looking, oh yeah, yes I can. Oh my goodness. So I can get it in a base 6, goodness gracious. And what I mean by that is, can I do 6 to the power of something gives me 36, right? Well, 36 is equal to 6 squared. So I can replace it with 6 squared. So I get 6 to the negative 3x equals 6 squared. Now I've got my same base, so I can set those exponents equal to each other. So I'd say negative 3x equals 2. Divide by negative 3. I get that x is negative 2/3. All right, let's try another one. Now, one thing I did do, if you go to this next page, I gave you base 2, base 3, and base 5. So if you see any of these numbers, know that you can change them to base 2, right? Like if I had a 32, I could change that to 2 to the 5th power. If I had a 625, I could change that to 5 to the 4th power. So kind of keep that in mind as you do these. How about let's go ahead, let's do this one. All right. So I'm looking and I have a 9 and I have a 243. So I want to try and get these in the same base here. That's a little bit tricky. So I look and I'm like, well, you know, do any of these work? Well, I noticed that base 3 has a 9 and it has a 243. So let's put this in base 3. I can rewrite this 9 as 3 squared, and then it's 2n plus 3. And then I can rewrite this 243 as 3 to the 5th, right? If I look back down at my chart, 3 to the 5th gives me 243. So now we have to use our rules of exponents. This is 3 squared raised to the power, so it's like 3 to the power of 2, that quantity to the power of 2n plus 3. If you recall, when you raise a power to a power, you multiply them. So if I multiply these guys, I just have to distribute, right? I would get 4n plus 6. So I could rewrite this as 3 to the power of 4n plus 6 equals 3 to the 5th. So now I've got same base again. Took a little bit of work, but I got there. And I can go ahead and take my 2 powers and set them equal to each other. I get 4n equals, 4n plus 6 equals 5. Minus 6, I get 4n equals negative 1. I get n equals negative 1/4. All right, so these problems are a little bit tricky. We'll do a couple more of these together in class, but definitely I want you guys to kind of start trying them on your own and see what you can